Okay, this lesson is on integration of log functions. So you know from the previous lesson that the derivative of log x is 1 on x. That means the integral of 1 on x must be log x plus c. Likewise, you also learned that the derivative of log of f of x is f dash x over f of x. So that means if you see, if there's an integral that you need to integrate where the numerator is the derivative of the denominator, then it's just going to equal log of the denominator plus c. Now here's another useful result, e to the power of log p equals p, and I'll show you why that is true. Let's just let the left-hand side, e to the log p, let's just let it equal x, and then we'll try and prove that x equals p. So with this equation here, if we take the log of both sides, and when I say log I mean the natural log, and we'll get this, and then using the log laws, then you know that you can bring the third log law, you can bring the power down the front. So that is equal to log of p times log of e, and you know that log of e equals 1. So this is just log of p equals log of x, which means that p must equal x. So that's why we've got e to the log p equals p. Very useful result. So, the integral of 3 on x. Now that is the same as 3 times the integral of 1 on x. Because with a constant, you can take that out the front of the integral sign. And then you just learnt that the derivative of log x is 1 on x. That means the integral of 1 on x must be log x. And because this is an indefinite integral, we will plus c. Okay, number 2, half is a constant, so we can take that out the front of the integral, just like we took the 3 out in the first example. And then we've got half, and the integral of 1 on x is just log x, and plus c because it is an indefinite integral. Okay, now this question here, we could do this two ways. You can either change 2x minus 1 to 2x minus 1 to the power of negative 1. But see, when that happens, I'll show you what happens. You get 2x minus 1 to negative 1. And you know that when you integrate, you add 1 to the power and divide by the new power. So add 1 to the new power, becomes 0, and divide by 0. But you know you can't divide by 0. So when this is happening, this is an indicator that maybe the integral is going to involve a log. So just get rid of that bit there. But the numerator is not the derivative of the denominator. So we've got to do a little bit of manipulating. So the derivative of the denominator is 2. So if we put a 2 up the top here, then the numerator would be the derivative of the denominator. But we can't just do that because that changes the value of the integral. So we could, though, put half out the front like that. And then the half times the 2 balance each other out. So now these two integrals are equal to each other. But now this integral is easier to integrate because you can see the numerator is the derivative of the denominator. So that's equal to half log of the denominator. And make sure you always put that denominator if it's two terms in brackets. And then plus c, because if you had written down half log 2x minus 1 without brackets, they are very different. Very different. So it's essential that you have your brackets there around it. So that is wrong. Okay, in number 4, integrating this one. Now you can see as well here that the numerator is almost the derivative of the denominator. The derivative of the denominator would be 3x squared. So it means we need a 3 there and a 1/3 out the front. And then you can see that it is log of the denominator, 1/3 log of the denominator. And then plus c, because it is an indefinite integral. Let's have a look at some definite integrals now. So same thing, but you just need to substitute in the limits. So the integral of 1 on x is log x. And remember, you put the square brackets, and then your limits. And you substitute in, showing your substitution. And log of 2 is log of 2, but you know log of 1 is just 0. So log of 2 minus 0 is just log of 2. Okay, in number 6 here, similar to that first example there, you could change it to 3x plus 2 to the power of -1, but then when you're adding 1 to the power and dividing by that new power, you'd have to divide by 0, which you can't do. So that means that's an indicator that this is a log. So how can we change this? Well, derivative of the denominator is 3, so let's see if we can put a 3 there and a third out the front. And that makes it a little bit easier. And we just also still need our limits, 1 and 0. So that's equal to a third log of the denominator, making sure that denominator is in brackets. And then we have our limits between 1 and 0. So we've got a third log, substituting in 1. You've got 3 times 1 is 3, plus 2 is 5, minus log, substituting in 0, you get 3 times 0 is 0, plus 2. And you could leave it like that, or actually, you know what would be better is using our log laws to simplify this. Log of 5 minus log of 2 is the same as log of 5 on 2. Like that, using that second log law. You can leave it like that, or you can write it as a third log of 2.5. And it's a definite integral, so we don't need to put plus c. Okay, the last question is a HSC question, so I'd like you to pause the video now and have a go at this question, and then once you've got what you think is the correct answer, then come back and check your answer with me. So, definite integral here, so that's the same as 5 times the integral of 1 on x between e cubed and e. And then that is equal to 5 log x between e cubed and e. So that's equal to 5 log of e cubed minus log of e. And now you can simplify that. You can bring the power 3 down the front of this log. So that's 3 log e. And log e is just 1, because you know that's a little base e. E to the power of 1 equals e. So that's just minus 1. And I guess you can see here as well, log e is 1. So that's 3 minus 1, which is 2. And 5 times 2 is 10.